how would you say that you approach quantifying spatial uncertainty and variability in geotechnical projects, and why is that important for tunneling design?
The whole idea about spatial uncertainty is very similar to how you're looking for an Airbnb. Almost all have similar prices for per night stay. And if you try to move away from your location and you look at Airbnbs at other different locations, you see the prices vary. So the whole point of, as you move away from your point of interest to a different point in space, things are going to change.
In tunneling design, spatial uncertainty refers to the unpredictability of geological and geotechnical conditions that can significantly impact the safety, the cost, and the efficiency of tunnel construction. This uncertainty can arise from various sources, including incomplete or inaccurate data, limited site exploration information, and the inherent variability of natural phenomena. In this episode, we'll delve into this critical topic of spatial uncertainty in tunneling design with Dr. Rajat Gangrade, who is a technical advisor at HNTB. We'll be exploring its causes, the consequences, and the strategies that geotechnical engineers can employ to mitigate its effects, from probabilistic modeling and sensitivity analysis to advanced site investigation and collaborative data management. We'll uncover the latest approaches and best practices for managing spatial uncertainty in tunneling design. I'm your host, Jared Green, and I'm excited to be bringing you another episode of the Geotechnical Engineering Podcast. And with that, let's dive right into today's episode. All right, Rajat, thanks for coming to the show. How are you doing?
I'm good, Jared. Thanks for asking. How are you?
I'm doing great. I was really looking forward to our conversation. I know you got a lot you're going to share that the listeners and those watching, they're gonna really enjoy this episode. So,
Hope so.
Yeah, if you could help set the stage, tell us a little bit more about yourself. Let us know why you wanted to become a geotechnical engineer and why did you want to focus in on tunneling, and how'd you get to HNTB? So there's a lot there, but take your time.
Yeah, a bit of my background. I was fascinated with my soil mechanics professor in my undergrad, and professor sort of left midway during the semester, so we had to complete the coursework on our own, and that sort of set the stage for diving deep into at least the undergrad curriculum and started looking at the basics and fundamentals of soil mechanics, and that got me interested. I was deciding upon selecting schools for my master's, and I was torn between choosing UC Berkeley and Virginia Tech. And I decided ending up going to Virginia Tech. I chose geotechnical engineering primarily because of my love for soil mechanics and soil behavior. And I was always interested on understanding why soils behave the way they behave. And I didn't think there would be any other place better than Virginia Tech to kickstart my professional career in geotechnical engineering. That's how I became a geotechnical engineer, I would say. Graduating with a master's degree, I started working for CH2M, which has now been acquired by Jacobs. When I was working in Midwest, I was in Iowa for about 2.5 to almost 3 years, facing some of the harshest winters of the Midwest US and drilling out in the cornfields, pretty consistent. The layer of loess and glacial till, so it became boring after a point of time, but it was fascinating. It was fascinating on understanding why are we drilling, where we are drilling, what are the consequences of our selection of locations of drilling, and that sort of led me into understanding what role a geotechnical engineer plays when it comes to large infrastructure projects. Was a great exposure. Always grateful for that experience. Things took a bit of a turn. I went back to my home country, India, and my city, Mumbai, where I was born and raised. And I started working as a geotechnical/tunneling engineer on a tunneling project. This was a 21-mile underground metro corridor traversing through the congested parts of the city. And my role was more around reviewing the geotechnical reports and developing geological profiles and understanding the behavior of the ground upon excavation and selecting tunnel boring machines. So quite a bit of role there with AECOM. And I had not experienced tunneling industry before this. This was my first exposure. At that point, I realized the amount of multidisciplinary action that goes into the tunneling field. And you pretty much get involved into the mechanical systems of the tunnel boring machines. You want to understand the ground behavior. At the same time, you are also diving, at least in the breadth wise, on the structural engineering side of it when you're looking into liner design and design of retaining walls and support of excavation. So I did dive into tunneling quite a bit, and I just became curious by about 2017. And I decided, well, I just want to know more about tunneling, and I want to know which schools in all over the globe offer a competent program in tunneling for a PhD. And it turns out that Colorado School of Mines had a program titled Underground Construction and Tunneling, and they were offering a degree in it. I reached out. My profile was quite decent enough by then with good geotech and tunneling background. So I was fortunate enough to get into a PhD program. I was mentored by Mike Mooney for 4 years. And yeah, that's how I landed up with a career in tunneling. I mean, I think during my PhD, I had great exposure working with tunneling contractors across North America. And that sort of gave me enough exposure on the kind of problems that exist within the industry and the kind of solutions that the contractors and the consultants and designers are looking for. So that sort of gave me the awareness of what kind of tunneling engineer I want to be. Once I graduated, I started working at Arup in San Francisco, and I started working as a tunneling engineer on one of the largest underground metro corridors in the world right now, which is the Bike to Silicon Valley Phase 2. It's a large diameter tunneling project here in San Jose, California. And I started working with Arup, and recently I switched jobs and I moved to HNTB. At HNTB, I am working on tunneling projects. My title goes as Technical Advisor in Engineering for Geotechnical and Tunneling aspects. And I'm working on tunneling projects in Seattle, in Los Angeles, and one of them in Texas as well. So it's been a great journey. I'm thankful I chose geotech as my specialization that I wanted to pursue.
Yeah.
And it just opened up doors towards the tunneling industry for me.
That's fantastic. That's fantastic. I was talking to students at a university last night, and one of the working on, I think she's working on her master's, considering a PhD, and she was saying, is there a lot of opportunity with geotech? And I was like, yes.
Absolutely.
And the reality is, like, there's so many different, when you start with the umbrella of civil engineering, there's a lot of things you could do. When you go towards, the aspect of geotechnical, there's so many different things you could do. And I love that with your background, you were pretty far into your profession and then saw a need to go back to get the PhD.
Right. Yeah.
And you probably brought to the classroom just a totally different flavor because you had seen things practically before, kind of delving more into theory to reinforce what you're doing practically. So really, really awesome experience. Really awesome experience. So I'd like to kind of drill down a little bit and, let's talk about spatial uncertainty. So how would you say that you approach quantifying spatial uncertainty and variability in geotechnical projects, and why is that important for tunneling design? You talked about when you were drilling, in fields at first, but now you're drilling into the earth horizontally. So how is that? What are your thoughts there, Rajat?
Right. Yeah, this sort of became a very interesting topic for me during my PhD and ended up being my PhD thesis. And the whole idea about spatial uncertainty I try to explain it to someone is very similar to how you're looking for an Airbnb. You look in a very, very solid geographical region and you see multiple options for renting out an Airbnb, and you see that almost all have similar prices for per night stay. And if you try to move away from your location and you look at Airbnbs at other different locations, you see the prices vary. So the whole point of, as you move away from your point of interest to a different point in space, things are going to change and things are going to vary. Spatial uncertainty quantification is all about quantifying how quickly things change. So it's basically, I try to stick it to Airbnb or a real estate example is because something that's a part of our daily lives and it's easy to understand. But now when we go underground and we look into a space that's around us in 3D, it's important to understand that soils and the way the soils are deposited, the geological depositional history just changes over a length in every direction. And that needs to be quantified. The reason it needs to be quantified is because ground carries one of the biggest financial and technical risks in geotechnical engineering and in tunneling. In tunneling, especially because we are fitting an engineering system underground for a period of 100 years or 120 years. And you want to know how the ground is going to behave, not over a period of 100 years, but how the ground is going to behave at the instant of excavation. And then how the ground is going to behave given that hydrogeological conditions evolve. There is sea level rise, the impact of global warming, water levels are going to rise or water levels are going to draw down, depending on that, how the ground is going to behave. So we need to understand that. And in order to understand that, we need to understand what is this ground made of and how things change, and at what rate do things change within this space. So it's extremely important to quantify because it all translates to what kind of risk are we looking at? Are we looking at sudden consolidation of ground just because there is a huge groundwater inflow? What kind of materials are present and how do they behave upon excavation? Do they flow into your TBM or the tunnel? Do the sands ravel? So it's important to understand that. And more importantly, when there is a transition between soil types or formation types where the formations have different mechanical engineering properties and they behave differently. So that sort of governs our type of design, our type of excavation, and those kind of transitions become extremely important to quantify. So spatial uncertainty and variability sort of sets the founding process or the founding stone for quantifying all these elements or the features in the subsurface.
That makes a lot of sense. And I think the reality is that, you don't want to learn about something like that during the actual,
Absolutely.
right? I mean, because the type of tunnel boring machine you're going to use, what type of cutters, like all that needs to be figured out before. You can't figure out during. And if you have a transition zone that you didn't account for, that's a lot of problems. That's a lot of problems.
There is an excellent resource, and this is for our listeners. There's an excellent resource published way back in 1984, I think, within the US. And then there was also a study done by the British Tunneling Society in about 2008, I think, where they accounted for or where they studied about 75 tunneling projects. And out of 75, I think 55 tunneling projects experienced some sort of ground subsidence or failures within the project only because of, and purely because of, inadequate representation of ground conditions during the geotech investigations.
Wow.
So it serves as a huge risk. And the spatial variability aspect just helps quantify that risk.
So let's see. So, talking about, spatial variability, let's talk about how that translates into risk for large infrastructure projects and how does it impact decision making? You hinted at this a little bit, but let's talk about it a little more.
Right. Yeah. So there are a few ways to quantify spatial variability that exist already. And I am talking about a methodology called geostatistics. So the power of these stochastic algorithms, and I say stochastic is because based on the geotech borehole data, the process generates multiple possibilities or realizations of ground conditions. So we are not looking at one deterministic profile that's being developed in CAD or that's being developed by an experienced engineer who is hand drawing it. No disrespect to the subjective engineering judgment of an experienced engineer, but that's the whole point of probabilistic approach, that we sort of start looking at multiple possibilities. And once we start looking at multiple possibilities, the strength is quantifying the uncertainty from these possibilities. So uncertainty basically gives you a level of confidence in how confident is the algorithm in predicting a soil type or a formation type or a rock type at a particular point in space. So the way this translates to risk is, depending on what your acceptance threshold of the risk is, we can define which are our areas of concern and which areas are typically not of concern. So for example, let's say we are tunneling under an open park and we have relatively high uncertainty below an open park space, but we can possibly take that risk because we are not impacting any surface structures with our operations. So even if something unnecessarily, or Murphy's Law, goes wrong, we will be able to take those consequences because we are not impacting anything above. But if we are tunneling under a large urban congested environment, even a slight amount of uncertainty can relate to high risk during our operations, and we want to mitigate that. So the uncertainty can be translated to risk in a way that risk can be defined or redefined. That risk is a product of your uncertainty and consequences. And that was a part of my PhD thesis, where the definition of risk just stems from how uncertain are you about the ground conditions? What does it mean for your operations in tunneling? And what are the consequences of it? And we can rank the consequences low, medium, and high. And if your consequences are about, all right, if my TBM gets stuck over here in this congested urban environment, I'll have to drill a shaft, take the TBM out, drill another shaft, maybe launch it again. That's tremendous amount of risk.
Yeah.
So, and that's tremendous. I mean, it has consequences. It has consequences on disturbing the community around you. It has consequences of delaying the project schedule and then probably incurring higher cost. So all of the decision on what is acceptable just depends on the designer or the contractor. But the uncertainty aspect just remains constant in the workflow. And then you can just define what level of uncertainty you are okay with.
Got it. It's wild because it's one of those things that, and I've been doing these episodes we've had so many episodes, right? And when we think about geotechnical engineering, you really don't know what you have until you're in it.
Exactly.
So, your statistical approach, I mean, there's no other way to do it, right? You can't just guess and just assume it's going to be one type of stratigraphy across the entire alignment of the tunnel. It's like you have to go through this process. Now, in going through that, we talk about communication a lot. I think that here would be great if you could talk about some of the strategies that you recommend for how to effectively communicate the uncertainty to stakeholders that are involved with these complex projects, because I know it's not the tunneling engineer that says that, well, this is the risk tolerance and this is what we're going to do, right? You have to explain that to so many different stakeholders. And what are some of the strategies that you've found to be effective in that type of communication?
Yeah, that has been a huge push within the tunneling industry right now, with few of the professionals trying to push for more probabilistic assessments than deterministic assessments. And we are trying to push it to get it incorporated into geotechnical reports or baseline reports, which are basically the reports for risk allocation between the owner and the contractor or the design builder. I think one of the greatest strategies is to just understand statistics a little more and see if we can define things in terms of confidence intervals. So, and in terms of probabilities. So, for example, a good example of that would be, let's say there are boulders expected along the path of excavation of the tunnel boring machines. And if we just simply have a statement in a geotechnical baseline report that says, oh, you're expected to encounter 20 boulders in the next 100 feet from station X to station Y, that doesn't necessarily capture all the uncertainty or the risk.
Yeah.
But if we say a statement like, or if we have a statement which is more sound and has more engineering insight into it, something along the lines of, there is a 95% probability that the number of boulders encountered between station X and station Y would be between 15 and 30. And that sort of just gives an insight, a better insight to an engineer rather than looking at one specific number. And it also sort of drills down on the confidence level of the assessments. If someone says there is a 50% probability, someone can understand that, all right, there is a half a chance that we might see it. But if the 95% is pretty confident that we are going to see between the two numbers. So I think one of the strategies is understanding and incorporating probabilities into our assessments. And second is visualizations. We need to move away from long paragraphs and long PDFs and large PDF samples. We need to move towards compelling visualizations that show our profiles in a very probabilistic way.
Yeah.
So I would say two things. One is the incorporation of probabilities, and second is the visualizations.
Got it. And I'm not a tunneling engineer. I mean, I've taken tunneling class, but I'm not a tunneling engineer. So none of that is code mandated or agency specific. It's really up to the engineer to decide that, or are we going to do a Monte Carlo simulation like that the engineer is deciding which approach to take, or is some of that mandated by the agency?
No, nothing is as yet mandated by the agency on what probabilistic methods to use. So it just lies as a free hand or an open canvas with the tunneling engineer in this case. And the best part about the tunneling industry is everyone is trying to solve similar problems. And there has been excellent research being done, good literature coming out of competent academic programs all around the world. So there are good examples of how these methodologies have been adapted to solve real tunneling issues and actual tunneling issues.
Got it. All right, cool. Let's shift gears a little bit. What are some of the ways that automation and digital development are transforming the tunneling and the geotechnical sectors?
Right. Yeah, that's a very interesting point. And especially when we are at the forefront of looking at things being done by AI. And
right?
We are
design a tunnel in 2 seconds, right? Just
we should be able to, so that people like me can no more be in jobs, right?
Oh man.
Well, I think that's a fascinating field. And I've always said this, and I've been saying this for past 8 years now, since I started my PhD, that the person who cannot code or cannot understand logics and cannot comprehend logics into something that can be automated will probably not be able to find a position by 2030 in this industry.
Wow.
Industries are slowly going to move away from hiring a pure geotech or structural engineer, and they are going to hire, or they're going to be looking for someone who's in the tech industry. These people are called ML engineers, which are machine learning engineers. But in our industry, they may be called something else. But they're going to move away from pure geotech and structural engineers and are going to hire people who have this combination of automation and ability to automate stuff with the background of the domain knowledge. So I'm not discounting that the domain knowledge of geotech and structural should not be paid attention to. It should be, because that is what is going to set you apart when it comes to having a combination of coding and a combination of your domain space. So we are in very interesting times. There is a huge push within consultants or design consultants and even contractors space to automate some of the complex engineering tasks that they carry out in their day-to-day operations. To give you an example, we do not want to look into designing a segmental liner, or these are the liners that support the ground when we excavate the tunnels. We do not want to do it, or we do not want to reinvent the way we do it in every single project. The steps remain the same. We go through the same process of selecting our geotech parameters. We go through the same process of inputting those geotech parameters into numerical modeling. We go through the same process of optimizing our numerical modeling runs, and then deciding on which locations we want to run numerical models for. And we go through the same process of extracting the results and then utilizing them to decide our reinforcement and sizing of the segments and everything. All of this is now being automated. And all of this can only be automated if the person who's actually running the models or actually is doing the automation and doing the scripting comes with the background knowledge of geotechnical engineering or structural engineering, because they are the one who can fine-tune the workflow and optimize the workflow.
Yeah.
Of course, as a geotech and structural, you can reach out to a digital delivery team and all the fancy tech leads in your company who can do coding in Java or Python or whatever methods they use. But you still need that geotech knowledge and who can optimize the workflow and make it more efficient. So it's a huge push. I have been at the forefront of it in my previous company at Arab, and we are trying to push for similar initiatives in contractor space as well. When there's a contractor who did a tunneling project recently in Sydney, and they had an autonomous TBM. And it's just fascinating to understand that the level of confidence they must have had in their automation system and all the data that all the sensors that are reading out the TBM data. There are about thousands of them.
Yeah.
All of that getting displayed on a computer screen, and then the system just learning from it and then excavating further. It's just amazing.
That's incredible.
So
that's incredible.
So we are at that forefront of technology, and as an engineer, I think it's our responsibility to adapt to it so that we can just make it better, and we can just make it better for the community and make it safer for our community.
Sounds great. So it sounds like as you're taking your soil mechanics class, you need to be taking some coding classes as well. Right? That's what I'm hearing.
Right. Maybe model all your effective stresses in Python right now. Yeah. So do it in Excel.
Don't do it in Excel. Don't do it in MathCAD. Right. It's like, no, it's good stuff. Yeah. It's one thing. We should always remain curious, and we should always want to learn new things. And we should never be afraid of technology. We should never be afraid.
Absolutely.
Yeah, you got to find a way to embrace it. Yeah, it's very important. So let's see. So, what are some of you hinted at some of this, but what are some of the trends and innovations in geotechnical engineering and tunneling that you think are going to shape the industry over the next decade?
Yeah, great question. I think automation and digital development is going to be one of them. I do have a gut feel that industries are, the geotech and tunneling industry are going to adapt more digital solutions than before. A good example of that would be just having a digital twin for a project, and then and having decision making and then risk assessment based on digital twins. And that is one aspect which I think is going to set the trend for the next decade or so. AEC, the architectural engineering and construction industry, they have been pretty successful at implementing such digital developments and automation level stuff. So I think I'm confident that the inertia will pass away, and there'll be more acceptance of such tools being really helpful. And second is obviously, I think, is going to be the acceptance of machine learning and AI. When I say AI, I think everything just falls under the umbrella. But the use of that black box, and many are still trying to understand what's inside the black box and how things change when you change something on your end. But I think there'll be more acceptance on the strength of machine learning and the type of problems it can solve. And whether it's resizing a foundation or deciding upon the termination depth of piles or support of excavations, I think all of those can be done using machine learning and sophisticated digital tools. So they're getting there. It's a huge push. The incoming workforce definitely plays a huge role into this. So they probably carry a much bigger responsibility than the existing workforce, I would say.
Yeah, no, it's true. I mean, again, they're learning it in school, so they're coming out with the understanding that this is available and it's possible. And it's almost like they have an opportunity to manage up and show us. Are you seeing, and again, don't share anything that's confidential, but are you seeing digital twins used in tunneling projects yet or not yet?
We are seeing them. and we are seeing them from two perspectives. One perspective is a contractor using it to understand how their project is shaping up.
Okay.
The second perspective is the owners using it at the end of the project just to see what happened when during the entire life cycle of the project, whether it was excavation or even just for asset management.
Mhm.
So just to understand if there is a future maintenance opportunity inside a tunnel, they should very well know what sort of operations they need to carry out. So digital twins are absolutely being used for all of that.
Mhm. Got it. I definitely see it on the asset management side.
Yeah.
That definitely makes sense. Makes sense. Let's see. So this is something you probably wouldn't want to talk about, but I'm going to ask you about it. Tell us about your recent UCA Young Member Award from the Underground Construction Association, and how is this recognition? How will it impact your role as a mentor to younger engineers in the geotechnical and tunneling industry? And of course, congratulations on your recent acknowledgement.
Oh no, thanks, Jared. Yeah, no, it was a special moment, to be honest, and it was an absolute honor to be awarded as the UCA Young Member of the Year. And I mentioned it in my acceptance speech as well, that this is more of a success for the UCA than a success level for me, because they have sort of inspired some random geotech engineer in Mumbai to come and pursue tunneling, and then they were very accepting of the fact that it supported all my endeavors of attending conferences through various scholarships. So we are talking about
Yeah.
we are really talking about community support in this space that I have received, and I think that was more of an honor than the award, I would say. I just loved the aspect of getting all the required support to build that career that I have right now. So yeah, thanks to UCA for that. If anyone from UCA is listening to this, you are responsible for my success, and I really appreciate it. I do feel it's a great achievement, and it sort of sets the tone for the incoming workforce should probably look for. They should look for more engagement within our community. They should look for more collaborations, attend more conferences, so that you can just speak to people and identify the kind of problems they face, and then just try to come up with solutions. It need not be a state-of-the-art, cutting-edge web application that you develop or an engineering paper that you write, but just speak to people and just identify the kind of problems they face and how you can be a problem solver.
Mhm.
So I really hope that my recognition sort of motivates and inspires the incoming workforce on the kind of path to take for building up a career in tunneling industry. And yeah, I'm here to help. Always willing to help out the incoming workforce.
Excellent. That is wonderful. Well, before we take our break, what's the final piece of advice you want to give to engineers that are listening or watching that are looking to grow in geotechnical and tunneling fields and also stay ahead of a rapidly evolving industry? What do you want to leave them with?
I think my blanket statement would be just be curious.
Mm.
Because if you're curious, you would start to look for things around you, and you would like to start to look for engineering problems or engineering solutions around you. And just second is just go out and speak to people. If you're my thumb rule is, if I'm at a conference
Mhm.
and if I'm not speaking to more than 30 people, I'm not making a good use of it. And this needs to be really good engagement on as questions as simple as, hey, what are you working on? This is what I'm working on. Have you heard about similar problems or similar solutions before? As simple as that. And that just sets the tone
Yeah.
for the future conversation. So I think being curious has helped me a lot. And I would just transcend that thought to the incoming workforce and younger engineers.
Excellent. Well, thank you so much. That was great. So we're going to come back in just a minute and close this one out, Rajat, in our career factor safety end segment. Stick around.
Thanks, sir.
All right, welcome back. It's time for our career factor safety end segment. In geotechnical engineering, just like many disciplines of engineering, it's important to incorporate a factor of safety into your design. But what about incorporating a factor of safety into your career? Today, of course, we're speaking with Dr. Rajat Gangrade, PE. Now, Rajat, when you think about the career that you've had, very successful career, when you look back, what is something that you've implemented in your career to give yourself, let's call it a factor of safety in your career?
Yeah, that's a good question, Jared. I think going back to school and achieving an advanced degree was a decision that I thought would give me a great factor of safety, and it did.
Mhm.
And the reason for that was at any point in my career, I thought this is a big investment into my own professional career and I want to do it. So 4 years of PhD were an investment into developing my own skills and the kind of skills that I wanted to build upon. Maybe just going back to school was good because I got to read the geotech books all over again. So that was fascinating.
Yeah.
And it just helped me become a better engineer because it just gave me a different perspective on the kind of problems that I want to solve and the kind of solutions that already exist out there. So that was one. And second, I can at this instant, I'm just thinking about was my network and the kind of professional relations that I have built over the years, and I look forward to build more professional relations. But that's a huge factor of safety. I think it's probably understated in our professional lives of how big help or a factor of safety your professional network is. So I'm thankful for both, and I think those were the two big ones for me.
Excellent. Thank you so much for that. Well, Rajat, thank you so much for coming on the show and sharing all these great insights with us. You share great information and advice. I know it's going to be helpful for our listeners and those that are watching. If somebody wanted to reach out to you, what's the best way for them to find you? You're on social media, or you have an email you could share, we'll put in the show notes.
Yeah, I am very active on LinkedIn. So
Okay.
LinkedIn is a place for sure. And then you can reach out to me on my email. It's my first name, last name at gmail.com. So we'll put that in the notes as well.
Okay. Excellent. Well, thank you for coming on. It's a lot of fun.
No, thanks, Jared. Yeah.
I hope you enjoyed the episode today. We would love to hear your feedback, comments, and or questions. Please feel free to go to geotechnicalengineeringpodcast.com, where you'll find a summary of the key points discussed in today's episode, as well as links to any of the resources, websites, or books mentioned during this episode. Until next time, we wish you the very best in all of your geotechnical engineering endeavors. Peace.